Student, this is high pressure homogenizer, and this can be called it as Manton-Gallin high pressure homogenizer because he only invented this high pressure homogenizer. So it is called as Manton-Gallin high pressure homogenizer. This homogenizer, it is going to be work for the cell disruption as well as for the homogenization of any suspensions or emulsion preparation. For all those purposes we can use the high pressure homogenizer, and the main principle behind this high pressure homogenizer is it will work on a reciprocating method. That means positive displacement pump principles. The mainly it is having a valve. This valve it is going to be open and closed. When it is open, the suction it is going to be take place. When it closed, it compresses the liquid. When whatever it is sucked from the reservoir, then it is going to be passed through the impact ring where the cell disruption is going to be take place. All the impact ring, valve seat, everything is going to be present inside this chamber. So there is a wheel. This is called as hand wheel. Through this hand wheel, we can increase the pressure from 100 to maximum of 1200 bar. And this hand wheel is having a provision of a spring rod that will give you a positive pressure towards the thing. The liquid which is going to be moved from this direction, when the pressure it is going to be given the opposite side, there will be impact it is going to be take place. This impact will make the cells to shear in the impact ring. Impact ring and valve seat is going to be present inside the systems. There are different types of valves are there. One is a standard valve, another one is a knife-edge valve, or conical valve, or a ball valve, like that grooved valve. There are different types of valve. This system is comprises of only a standard valve. Through the standard valve only, the liquid is going to be flow into the system in a form of pulsating flow. Once it is going to move in the positive direction, there is a restriction is going to be there. This restriction will make the liquid to come backward. When it is going to be come backward, it is going to be passed through the impact ring. In the impact ring only, the cell is getting disrupted. So this is called as the pressure gauge, which is going to measure the pressure, applied pressure inside the systems. The working principle is very simple. It is only suction and delivery. When suction is going to be takes place, it will suck the liquid from the reservoir, and it is going to be delivered. And it is going when it is going to be delivered, there is a small opening, small clearance is there. Through the clearance, the liquid is going to be come out of the system. So there, the impact ring is there. Always the impact ring is going to have a gear and gear thing. So it will get in gear. So how we need to give is when you are moving the handle like this, we can increase the pressure whatever we need to have. The principle behind everything is based on the first law of dispersion only. First law of dispersion, I already told that it is ln of 1 minus r is equal to minus kt. Here instead of t, it is a function of n and p. N is the number of passes, p is the pressure applied. So in our single equation, ln of 1 minus r is equal to minus k into n power p. Either n can be changed or p can be changed. We cannot change both simultaneously. N means the number of passes. The passes is nothing but we can correct it from the exit, and it is going to be transferred to the top. So this is called as pass. Either we can change the pass by keeping the pressure as constant, or we can keep the pass as a single pass. For the single pass, for various pressure, what is the change in the cell disruption, that we can able to calculate, or we can able to do. So in this system, what I am going to do is I am going to pass the culture for 100 bar, 200 bar, 300 bar, up to 500 bar, 500. Pressure? Yeah, up to 500 bar we are going to pass. For a single pass, we need to collect the sample from the exit, and this can be checked through the spectrophotometer. Using Bradford method, we can analyze the amount of protein released from the system. we need to do is, for example, 100 bar means I keep the pressure as 100 bar. For this 100 bar, now for a standard we are just running the water. We need to pass the culture to the system. Once the level is going to be come to this level, bottom of the conical. So up to this level, when the water drain out, then we need to top up with the culture. And once we are collecting, we need to collect the sample in the effort of it. Then again, the next culture has to be passed through the system. Like that, we have to go for the culture of 200 bar, 300 bar, 400 bar, like that. See, for 100 bar, we just pass the culture. So whatever it is disrupting, we need to collect the sample. See the pressure, it is going to be, we need to adjust it to exactly 100 bar. For this 100 bar, like this we can collect the sample, and 1 ml of the sample can be analyzed using Bradford method. Next thing is, we can go to the 200 bar. For the 200 bar, we are collecting sample. For 200 bar, we are collecting sample. And again, I just turn it to 300 bar. Then we can raise it to 400 bar. Again, then once if you are giving the pressure, you wait for a while because the culture has to be transferred through the system. Then for the 500 bar, we can collect the sample like this. All this from this sample, 1 ml of the culture can be taken and it can be analyzed through the Bradford method. That's all. After that, through Bradford analysis, we are getting the protein concentration from various level, from 100 bar, 200 bar, 300 bar, 400 bar, 500 bar, like this. This can be measured through the spectrophotometer, and the values are, we will show it again later. Stop and pass.